Welcome to the lecture series on research methodology sampling methods for science students, presented by Mr. C.P. Swami, Mrs. T.S. Arekar, Mrs. S.D. Vatkar, Department of Statistics, Tuljaram Chaturchand College, Baramati. So, students, today's our outline of talk is types of statistical data, population and sample, sampling methods, probability sampling methods, non-probability sampling methods, and survey. All these topics are related to research. So let us start. Research methodology is the specific procedure or techniques used to identify, select, process, and analyze information about a topic. In a research paper, the methodology section allows the reader to critically evaluate a study's overall validity and reliability. For these, case studies, checklists, interviews, observation, sometimes, and survey or questionnaires are all tools used to collect data. It is important to decide the tools for data collection because research is carried out in different ways for different purposes. So let us begin with definition of statistics. Statistics or statistical method is treated as a branch of science which deals with collection, presentation, analysis, and interpretation of data. We have seen same things in research methodology also. So first we will start with the data. So what do we understand with data? Data, we define it as quantitative information about some particular characteristics under study, or we simply call it as information that we collect. So for data collection, we can use two types, that is primary data and secondary data. Primary data is original data, that is facts and figures obtained by investigators himself. It is also called as raw data. Primary data, when it is collected, you can use questionnaires there, you can do the surveys there, and you can collect the data for yourself. Now the next is secondary data. Data taken from sources like office records, bulletins, reports, etc. is known as secondary data. So simply we know that the data which is collected by any other person or any other agency is known as secondary data. It is also called as finished data. So whenever we are talking about the data, we should know that there are two types of data, primary data and secondary data. While studying any phenomenon, we come across two types of characteristics, that is variable and constant. Here you can find from the chart that we have divided the statistics data in variable and constant. So variable is any characteristic, number or quantity that can be measured or counted. So we can say that a characteristic which changes its value is known as variable. For example, height, weight, length, etc. So here we find that height of all the students in a class is different. So height is varying. Also the weight of students is also different. So weight is also varying. And the length of the different plants or different leaves of any plant can be differ from each other. Biology students can take examples of variables as the water used for planting a plant, or height of each plant is also different. So this is the variable. Here you can also find that the soil type is also different. So they are also variable. So what is the variable? It is the variation between the two things. Related examples we can take is, you can find that temperature on any particular day is different. Amount of rainfall is different. Every day we are measuring the rainfall and we find that the amount of rainfall is different. Speed of any vehicle traveling on road is different. So whenever the breaker is there, you are speeding down the speed. So these are some of the variables, and more examples we can say is capital expenditure, class grades, business income, etc. So these all are the examples of variables. Now next we come to constant. The characteristic which do not change its value is known as constant. For example, after a certain age, height of a person is constant. Then we can say that charge of electron, it is minus 1.6 into 10 raised to minus 19 C. It is also fixed, so it is also constant. Or speed of light in vacuum, that is 3.00 into 10 raised to minus 18 meter per second. So it is also constant. So we can take the different examples for the constant. So from constant's definition, we know that the value which is fixed is known as constant. So primarily we find that statistical data is divided into two, that is variable and constant. Now next, moving to the variable, we divide again it in two parts, that is quantitative variable and qualitative variable. According to the name suggests, quantitative variable is related to quantity, that is we know that quantity can be measured in units, 1 kg, 2 kg, 10 kilometers, 5 kilometers, or any of the characteristics that is having the units. So this we can say as quantitative variable. And the same qualitative variable, further we will call it as attribute. Qualitative variable suggests us that there is some quality related to the that particular product. So we categorize data into two, that is quantitative and qualitative data. Further, we call it as variable and attributes. Now we have divided quantitative variable into, that is discrete and continuous. Discrete variable. So discrete variable, a variable which takes only particular values in the given range, is called discrete variables. Or a discrete random variable is one which may take only countable numbers of distinct values such as 0, 1, 2, 3, 4. So for example, number of accidents on a particular highway, we can count it in numbers. Second is number of defectives in a lot, that also we can count in like a number. Next is number of mistakes per page, and so on. These examples, you can count the change in your pocket or money in your bank account. This type of example comes under the discrete variables. So let us take some more examples here. The number of offsprings, the number of colonies of microorganisms or animals, or the number of plants in a given quadrant. All these are the examples of discrete variable. Now next we come to the continuous variable. A continuous variable which takes all possible values in the given range is called continuous variable. So see what we are saying here, that when the particular values are taken, then it is discrete variable, and all possible values that are taken in a particular range is known as continuous variable. For example, again the height of a student. So height of student we take for graduation students, it would be from 5 feet to 6 feet or 6.2 feet. We can take it like this. So here we are taking a range. Similarly, weight of students, so we can say that it is from 50 kg to 80 kg or 45 kg to 80 kg. So this is also again a continuous variable. Temperature, so temperature also comes in a range, so it is also a continuous variable. So here some common examples of continuous variables are lengths, area, volumes, angles. You can find that angles we can measure it from 0 to 360 degree. Whichever angle you are measuring, you are finding that it is in between 0 to 360. So it is a good example of continuous variable. Next, it comes for temperatures. Whenever we are measuring the temperatures, it is also in a range. So it is again continuous variable. Period of time, whether it is 1 year, so again there are 12 months. whether it is 1 month, that is 29 days, 30 days, 31 days. Again, we are having a range that is 0 to 30, that is 1 to 31 days. Percentage we can call, but percentage we never say that is it is 120%, it is 100%. So we can say that it is up from 0 to 100%. Whether the value can be 80%, 90%, but it comes in between 0 and 100, and the same is the rates. So here we find that types of statistical data is converted into two or categorized into two, that is variable and constant. Again, variable is divided into two parts, that is attribute and quantitative variable, or we can call attribute as qualitative variable. So qualitative and quantitative variable, and we find that quantitative variable is divided into two, that is discrete and continuous variable. So I think you have understood up to this, that is the types of statistical data. Next, we move ahead to the next part of this. So here the definitions are given. Types of statistics data: constant, that I have told you. The characteristic which does not change its value is considered as constant. Variables, a characteristic which changes their values, such characteristics are variables. Then next, coming to qualitative variable and quantitative variable. So as I told you that qualitative variable, it shows some quality. Here the example is examination result of a candidate recorded as pass or fail. Here we can't say that he is 20% pass or 20% fail. Here the results are pass or fail. And same thing, quantitative variable, same result we are taking, but here we are expressing the result into the percentage of marks. So we can say that the number we are getting. So what we are getting? We are getting a quantity. So here the percentage of mark is quantitative variable, and pass and fail of the examination result is qualitative variable. So I think you understood all the things related to statistical data. Next, let us move towards the next topic, that is attributes and variables, which is very important in our research. So whenever a researcher is planning to do a research or a survey, he should understand the difference between the attributes and variables. So I find that you have understood what is variable and what is attribute. Again, we will go for attribute, that is a characteristic which is qualitative in nature and non-measurable. See, here I am saying non-measurable. So non-measurable is known as attribute. Now, how it is non-measurable? So look at the examples. Literacy. Can we say that literacy is measurable? Can you say that he is 20% literate? No. We can say either he is literate or illiterate. So here we can't measure literacy. Second is religion. Here we can say that he is either Hindu or Muslim or Jain, Sikh. So these are the religion. So we can't say that the percentage of religion he is. We can directly say that he is either Hindu, either Muslim, or Jain or Sikh. So the next is coming towards the next, nationality. So you can say his nationality is either you can say that he is Indian, he is Chinese, he is Pakistani, like this. So here we can't measure the things. So gender can't be measured, nationality can't be measured, religion can't be measured, grade in examinations. So the grade you know well, O plus, A plus, you can't measure. Yes, if he is O, then yes, he is outstanding. Then A plus, then he is having the distinction marks. Here you can categorize that O, A plus, A, B plus, B, and so on. Same thing with blood group. If any person is tested blood group, then it is either A, B, A plus, B plus, O negative, and so on. We can't say that there is a mixture of A and B, or we can't measure that 20% is A or 20% is B. So we can't measure blood group, entire blood group is 1 in a 1%. Person to person, it can be differentiated or variation can took the place. But here, talking about 1%, it is only one blood group. Qualification also you can find, that is, it is he or she is either graduate or non-graduate, either postgraduate or non-postgraduate. Here we can't say that he is 20% graduate or like this. Occupation also, we can differentiate the occupation in job or business. So occupation is also a type of attributes. And these type of various attributes we can find. Some more examples will crystal clear it, that is defectiveness of an item. You can directly say it is defective or non-defective. Beauty, you can say beautiful or ugly. Then deceased, you can say it is that particular person is deceased or non-deceased. Color of any flower, you can say that it is red, green, yellow, and so on. Mostly in research work, we use qualitative type of data in our questionnaire. In current situation, the relevant example would be, so I am going to COVID situation. In 48 hours, have you had any of the following symptoms? This is my question. And the options that I have prepared here is cough, chills or repetitive shaking with chills, trouble breathing, shortness of breath, sore throats. So 5 of these options I have given. I am repeating the options here. Cough, chills, trouble breathing, shortness of breath, sore throat. So these are my 5 options. Here, if you are suffering from cough, then you have to tick on cough. Here, if you are suffering from trouble breathing, then you have to put the tick on that. So these are some of the example. This is the example of the attributes. So what we have learned about the attributes, that attributes is a characteristic which is quantitative in nature and non-measurable, then this type of variable is known as attribute or qualitative variable. Now we divide it into 2 parts, nominal scale and ordinal scale. So starting with nominal scale, let us see what is nominal scale here. Nominal scale consists of 2 or more named categories. See here what I am saying, named categories into which the objects are classified. For example, classification of individual using gender. So whenever you are filling a form, you have find that write the gender here. Either you tick on male, female, and like this. Nationality, then again the nationalities are given there. It is Indian, Chinese, and Japanese, Algerian, and so on. Same comes with blood group. So blood group, you may have A positive, A negative, O positive, O negative. Qualification, you can see here, either you are graduate, you are postgraduate, you are doctorate, you are HSC, you are HSSC. So these are the some nominal scale. So what we understand from nominal scale, that there is a named category into which the objects are classified. So more examples we can say, mobile numbers, house numbers, survey numbers, pin code numbers are also example of nominal scale. So whenever you are calling that 413133, the pin code is from the MIDC of Baramati, and whenever you are calling that 413102, then it is from the city area of the Baramati. So here we are differentiating it according to category. So what we understand with nominal scale consists of 2 or more named categories. Here again, if you are doing a survey related to blood group, then you are having the options here, A plus, B plus, A minus, B minus, and you are having the tick over there. So here we have seen that mobile numbers are taken. We can take the mobile brand also, whichever brand you are having, Samsung, Nokia, then Redmi, then Apple. So that we are categorizing the mobiles into different brands. So this is the example of nominal scale. So biology students can take the plants also, Then the zoology students can take the species also, the different species that coming under a one. So you can take the nominal scale as the named categories into which the objects are classified. Then coming towards the next, that is ordinal scale. Ordinal scale, as the name suggests, we can say that ordinal scale of measurement gives numbers of groups of objects using some quantifiable characteristic. Now, what is this quantifiable characteristic? So, see, whenever we are giving the ranks in a class, the student is taking the rank. So, it is in the order. So, this is the ordinal scale. Therefore, ordered arrangement of groups is possible in this scale. Group of individuals according to income, such as poor, middle class, rich. We can categorize that he or she is comes under the poor category or middle class category or rich category. Second, and it is through the orders. First we take the poor, then middle, then rich. We can revert the order also: rich, middle class and poor. Then groups of students according to grades in examinations, such as first class with distinction, first class, higher second class, pass class, and fail class. So these are some of the examples, and more I have told you that whenever we are taking this type, so sometimes we are filling the form and we are giving the order to the particular particular product, that it is good, first, better. So it is in the sequence. How I am saying, it is not like that. It is the first is worst, then the second is good, then the third is better, then it is best or excellent. So here you are, what you are doing, you are making the order here. You are giving the orders here. So the more examples for the orders are, that is groups using heights such as short, medium, tall. You can say she is short heighted, or he is medium heighted, or he is tall. So here you are giving the order there, and you are getting the data, or you are getting the number of short heighted, medium heighted and tall persons there. Similarly, groups of individuals as dull or intelligent, groups of objects as soft or hard, are all situations where ordinal and the ordinal scale can be used. So here we find that in the ordinal scale, numbers given to groups as labels serve the purpose of ranks. Hence, those labels are not interchangeable. In the ordinal scale, the groups are ordered according to some characteristic. Suppose three individuals A, B, and C are given ranks 1, 2, 3, respectively, according to height. So what we find here, that A is the shortest and C is the tallest. In this case of heights, A, B, C may not be equispaced, however they possesses the equispaced ranks. So what we understand with ordinal scale of measurement gives numbers of groups of objects using some quantifiable characteristics. Now next, we have understood the variables. A quantitative characteristic like weight of person, examination marks, population of country, profit of salesman, etc. are variable. Variable are measured using interval scale and ratio scale. So as I have told you that whenever we are using a unit for any characteristic, then it is the variable. So we find two scales for measuring it, that is interval scale. So interval scale of measurement has equal units of measurement. However, 0 point is arbitrary. The classic example of our interval scale in our day-to-day life is the centigrade or Fahrenheit scale of temperature measurement. In both the scales, 0 is arbitrary. It does not mean absence of heat. Moreover, 60 degrees centigrade does not contain exactly double the heat that 30% degree has. However, the difference in temperature between 10 degrees centigrade to 20 degrees centigrade is same as that between 50% degree centigrade to 60 degree centigrade, or that between similar pair. So this is the interval scale where you can find the interval here. Next is ratio scale. Ratio scale of measurement has equal units of measurements, and those are taken from a true zero. For example, all measurements of type weight, that is kg, height, centimeter, time, hours, etc. are the examples of ratio scale. It can be clearly noticed that variables can be measured by numbers. Further, the variables are divided, as I have told, between discrete variable and continuous variable. So, what we understand by variable and attributes here? Variable, a quantitative characteristic, and attribute, a qualitative characteristic. The best example I am going to give you here is examination result of a candidate can be recorded as pass or fail, which is qualitative variable characteristic, whereas we can express the candidate's performance as percentage of marks, which is a quantitative variable. So see, here we are taking the result of a candidate, and when we are saying it is pass or fail, then it goes to attribute, and when we say that it is the percentage of the marks, then it goes to quantitative variable. So this is the basic difference between the variable and attributes. For variables we need the units, and for attributes we don't need the units. Secondary variables are countable and attributes are non-countable. Variables are measurable and attributes are non-measurable. So up to this we have studied that statistical data is divided into two, that is variable and constant. Again we have divided the variable into two, that is quantitative variable and qualitative variable. Next we have divided the quantitative variable into two, that is discrete variable and continuous variable. Then we have seen that the scales are there. For attributes, we can take the scales as nominal scale and ordinal scale. Nominal scale, which is based on the categories of the object. Ordinal scale, which is based on the order of the particular object. So next we come for the interval scale. There is an interval, then we say that is interval scale, and whenever we are measuring the ratio, then it is the ratio scale. Then clarifying it, we can say that nominal scale and ordinal scale can be used for attributes, for measuring the attributes. Similarly, interval scale and ratio scale can be used for measuring the variables. So we have learned about the statistical data. Now the next point of the topic is population and sample. As in the first topic, we have learned about types of data, that is primary and secondary data. The methods of collection, that is data collection, are survey, laboratory experiments, and simulation. So here we find that when we are collecting the data, then there are two types, that is primary data and secondary data. As we know that primary data means original data, which is related to facts and figures, and secondary data, that is taken from the sources like office records and so on. So the basic difference between primary and data we find is the collection method. How we collect the data. This is the difference. Primary data are original in nature, while secondary data is the finished data. So as I have told you that surveys, laboratory experiments, and simulations are the ways for collecting the primary data. So talking about the surveys, with the help of sample survey or complete enumeration, primary or secondary data can be collected. Next, laboratory experiments. The observations generated in laboratory experiments will be a method of data collection. And the final simulation, some experiments cannot be conducted in laboratory. For Example, genetic experiments, experiment with hazardous material or radioactive material. So in this case, we simulate the data. Some other type of data is like time series data and cross-sectional data. Time series data, the data arranged in the chronological order. Now here the chronological means as per the order of occurrence are called as time series data. For example, daily sales of a departmental store, daily electricity consumption of a town, price of gold recorded daily. And about cross-sectional data, the values of variables observed at a particular time at several places on or several objects are called as cross-sectional data. Cells, we can take the examples like cells on a specific day of several departmental store is a cross-sectional data. Similarly, electricity consumption on a specific day for several towns constitutes cross-sectional data. However, daily electricity consumption of a specific town is a time series data. So the difference between time series data and cross-sectional data is that time series data, the data is arranged in a chronological order, while cross-sectional data observed at a particular time at several places. Yes, moving towards population and sample, we have heard the word population many times. Many times we see that population, we talk about the human population. Now, in technical language of statistics, the word population is used in somewhat a wider range. It does not mean only a human population. For example, in the study of industrial development, all the industries under consideration is the population. In the study of socio-economic conditions of a particular village, all families or houses in the village will be a population. In the study of agricultural yield, all the cultivated farms together will be a population. So here, population not only means the number of human beings in a particular area, it may consider a group of employees, collection of books, total industrial production, and so on. So in statistics, we can give the definition like an aggregate of objects or individuals under study is called population or universe. Population may contain finite or infinite elements. Accordingly, it is called as finite or infinite population. Now, statistically, we have defined population as an aggregate of objects or individuals. However, many a times we record some quantitative or qualitative characteristic of each manner in the population. These observations are collectively called as statistical population. In order to study the population, one of the ways is to collect information about each and every element in the population. And this method is known as census or complete enumeration. Census, the method of collecting information on each and every unit of population, is called as the census or complete enumeration. But some of limitations are there for census method. So we find here like census method provides reliable results, but due to voluminous work, it is expensive and time consuming. And sometimes it is not possible also. So for example, while purchasing food grains, you are not going to see or check all the grains in that particular set. You will see, you will find a handful of grains and draw conclusion about the quality of the whole lot. Similarly, for testing quality of milk, a small quantity of milk is tested instead of entire bulk. We are not able to test whole of the milk. So here we find it easy to test some of the milk and draw the conclusion for the whole bucket. Similarly, whenever a housewife confirms whether the food is properly cooked or not, with the help of few particles taken out of the container, clearly the food in the container is a population, whereas food taken out of the container for inspection is a sampling. So the next method is introduced here, that is to find a sample and to draw the conclusion. A small representative group of units for the population is called as a sample. The procedure of drawing a sample is called as sampling unit. So the procedure is known as sampling. So here sampling unit, a member or element of population are called sampling units. Talking about sampling frame, it is exhaustive list for map of all members or element of population. If the population is infinite, so census cannot be used there. At that time, we are going to use the sampling method. There are some situations where census is not possible but impracticable. So here we find the sampling method as easy. In order to overcome the limitations of census, sampling is used. In this case, some representative items are selected from the population so that all important characteristics of population are covered in the items of the group. Such a group is called a sample, and the method of selecting such a group is called a sampling method. So what we have learned up till, that is population, census, sample, sampling unit and sampling frame. What do we understand with population? An aggregate or totality of units or individuals under study is called as a statistical population. The number of units containing in the population is called as the size of the population, and it is denoted by capital N. So two methods we know for measuring the population, that is census and sample. The method of collecting information on each and every unit of the population is called as the census or complete enumeration. A small representative group of unit from the population is called as a sample. The procedure of drawing a sample is called a sampling procedure. So up to this we have learned. For example, if talking about the examples, we can say that if I have to draw a conclusion about the TC college students, then whichever method we can use, but I think sampling method is more better than the census method. Now we are going to see advantages of sampling over census. So some advantages there are related to sampling over census. Now 4 points we can see here: time, cost, accuracy and wider scope. So time, that is, it reduces time. As compared to census, sample consists of a less number elements. Hence, there is a considerable reduction in processing time. The results can obtained quickly due to time saved in data collection and further analysis. So here we can say first point is reducing the time. As for census, each and every unit is to be tested. While sampling, we can take a small part from the population and we can test, so the time is very less there. Next it comes for the cost. It reduces the cost also. There is reduction in cost both in terms of time and manpower. Sampling only a part of population is under consideration. Therefore, expenses incurred of collection of data and its analysis are always less than those in census. Thus, sampling is economical. That is, it takes small cost or less cost. So we find that it reduces time, it reduces cost. Now let us see about the accuracy. Only limited number of units are to be investigated in sampling, and so accuracy will be increased. The volume of the work is less in sampling, so it can be completed efficiently. As compared to census, only limited number of elements are to be processed. Therefore, sophisticated machinery, well-trained staff can be used and accuracy can be increased. Due to the reduced volume of work, it can be completed efficiently and without fatigue. Samples will be free from non-sampling errors such as incompleteness of returns, biasness due to interviews, inaccurate results, returns, etc. Next, coming towards greater scope, if the population size is very large, census is impracticable. In testing destructive items, there is no alternative to sampling. For example, in testing the life of a bulb, every bulb cannot be tested. In testing human blood, in testing the strength of bomb, in testing quality of glassware items, there is no alternative to sampling. Whenever we are testing the blood, we take a sample instead of whole of the blood from the body. So here we see that sampling is having the greater scope than census. Now taking much more examples here, suppose a company manufactures a remedial medicine for a certain disease. All the patients suffering from the particular disease may not be ready to try the newly manufactured medicine. In this case, sampling has larger scope than census. Secondly, in testing a destructive, that is, element gets destroyed in analysis, sampling is only the alternative. Testing the life of the bulb, testing strength of building construction material, testing fat percentage of milk, testing human blood. So all these things are um, very sensitive, and here we can't use sensors. We have to use sampling methods only. So advantages of sampling over census, we find that it reduces time, it reduces the cost, accuracy is also good, and wider scope is there for the sampling. So here we have studied population and sample. So what is the meaning of population here? The data that is under an aggregate of object or individuals under study is called population. And what about sample? A small representative group of units from the population is called as sample. So many more examples you can find for the population. If we are taking the population from the TC college, again all of the students will be there and we have to test only sample. Few students we can test. For sports also we can take for sports students we can use the census method here, and these are some of the sampling units and sampling frames